Okay, I'm going to go over exam one, part number one with you guys. You did very well, better than I thought. I initially thought maybe you had not done very well. So I'm in the edit mode for this exam so I can go through each item and we can talk about them. And just to start with the details, it was you had 2 hours to complete it. You had 40 items, and I allowed you 3 attempts, and I kept the highest score. Those are the settings I had, and this has been, and I showed the correct answers at 7 p.m. I decided to shut it off at 9 p.m. So I'm gonna go and through the rest, and then into the questions now. Okay, and we're going to go through that. First of all, this is given the sets where A, B, C equal A is 1, 2, 1, 2, 3, B is 4, 5, 6, 7 is 8, 9, and the set notation is this: when you see this little inverted U, that means an intersection. When it's a U, that means that you're talking about a union. And I'm going to click on here to edit this question. Let's go load the question. And it was a set equivalency question. Okay. And I'm going to come up here and increase, if I can, the font. Back up here to the size that we want it to be. I'll put it up to 24 font. Okay, this is given sets A, B, C, where A equals 1, B equals 2, B equals 4 through 6 equals 79. And basically what you're looking at here is the intersection of A and B. And that is, what elements do they share that are the same? Okay. And it's a set equivalency problem right here, as you can see. Now, the intersection of A and B is 0, because, or no, there's nothing that they share. And then the next, and then you say, okay, is there anything between that set and the intersection with C? And that's a null set, because the intersection of A and B, that is, everything in A and B that match, there's no match there. And there's no match in that empty set with this set. Okay? So it's a true answer, because this right here, this section, is talking about A as an intersection with the union, with the intersection B and C. B and C share no items. So that's an empty set. And then that set right there does not, there's nothing that intersects there. So the answer in that one is true. Okay. And I, in fact, see the course materials in set theory and Boolean algebra. All right, let's go to the next one. A spreadsheet can be let's put this into larger font. 24 font. Single spreadsheet can support multiple charts or graphs. That certainly is true. We've seen that over and over and over. Okay. So now let's go to the next question. Spreadsheet requires here's this next question, and we'll take the font. Let's make it 24. So the spreadsheet formula requires one equal sign for each function. No, as when we did nested statements, I showed you from that first case number 3, we started equal and if, and then you may have an and or an or, but a spreadsheet, but you don't have to have one equal size sign for each function. So that's false. So that's false. Let's go to the next question. Okay. I said it did. Well, let me back up for a minute. Basic structure of any algorithm. I'll make the font bigger so you can see it. I'm in edit mode here so you can see. A blank is the basic structure of any algorithm. And as you scroll down here, the correct answer is sequence. So you should have had sequence. And that's from the algorithm development. There's a PDF over there. As I shared with all of you, exam 1 was drawn from those materials in that supplemental website, and I also went so far as to give you a sample exam. Okay, so and that's why you did well on it. So I'm real happy. I was afraid that everybody didn't do well, but you did. All right, here's the next question. And I'm going to get these fonts up a little bit. I'm in edit mode on this. All systems have what? Okay, and scroll down here. And I gave you input, process, output. And the correct answer is all of them. We talked about systems, and there's a systems theory PowerPoint. But I also have said many times, and when we talked about spreadsheets, the input, output area. So all systems have input, process or throughput, and then output. So that was one we should have done. And let's see, we're through that question now. Let's look at the next one, and we'll edit it. Assume not P implies Q. And let's take that up, the font up a little bit. Assume that not P implies Q. So anything that's the opposite of P implies Q. That's the word not. So if P is false, Q is true. And that's correct. The reason is it's a logic question. If not P, anything but P implies Q, and P is false, then Q is true. And I tell you correct. I tell you to see Wilson, page 56, and the link. There's a link over there on truth tables provided in the supplemental website. So you have to think about this, not P. So it's anything but P implies Q. So anything, if you take P and take it out of the set, all the other letters of the alphabet, for example, imply Q. So all the other letters imply that Q is true. Then P is false, Q is true. Because what is not P, that is anything but P, implies Q. If Q is true, then P has to be false, because not P is the opposite of P. Set theory. Let's look at another one. Here's another. Assume not P assumes. Font up a little bit. Assume not P implies Q. If P is true, then Q is false. That is correct. This is just the opposite of the earlier number. And again, I tell you, see the Wilson, see the lesson on truth tables. There's a link there. Here's a question about spreadsheets. And again, this is the same stuff, folks, that almost verbatim the sample exam. So everybody did well, and you should have. A few of you had some problems. I was afraid I'd have to grade the curve of these, but I don't think I'm going to have to, because I have too many people who got perfect scores. Data can be displayed in a spreadsheet. Cell can be centered. I mean, that ought to be a no-brainer. I mean, you know, if you've had the 1103 course and then you've had this, and then you can center data in Excel. So I kind of laugh, but I mean, come on, you know this. So that should have been a gimme. Let's see, data stored in a spreadsheet can be graphed. Let's do this. And I'll take the font up. Yes, the data is stored in a string because we've been using graphs and we've been doing it, okay? It's just simple stuff, no big deal there. But I also told you the page 60, that would be when we solve it. Data is sorted in a spreadsheet. Can be sorted? That's the question. I'll get it up to a large size here where it can sit. Yes, we can. Data stored. We did. I showed you last night. We've done sorts and filters. Excel includes only function for the computation of standard deviation. Okay, let's look at that one. That's false. It has standard deviation for the population and it has standard deviation for the sample. In fact, when it's certainly over there in the Solve It book. You could have opened up Excel and taken a look in the functions to see that there's a population standard deviation and a sample standard deviation. So that answer is false. It does two different computations, and the computation for the standard deviation of the population is different than the one for the sample. Excel precludes users from developing their own functions. That's false. Okay. And you can go down there and when we did the payroll function, when we did the payroll case, very first one, Guardian, I told you we developed our own functions here, and we did that rolling FICA. So yes, you can create your own functions in Excel. So this answer is false. That would have been the correct answer. Let's go to the next one. Excel does not allow users to write their own computing code. That's false. And I tell you, okay, the answer is VBA. I've talked about that. VBA, Visual Basic for Excel. I've spoken about that. Visual Basic for Excel allows you to write your own computing code to tailor things. And I think I even took us down in one of the cases down to take a look. But I also, you could have gone out and done a search. You had a computer in front of you when you took this exam. I didn't lock down your browser and say, no, you can't go out and do a search. I told you so. Look up and no. Excel date and time. Excel has date and time functions. Yes, we use the equal now. How data. I showed you last night when I did Excel S10 about dates. So that certainly is true. And we'll just pop on here. It's true. And you can also see the Excel toolbar if you want, for that matter. Provides features for forecasting future values of data. That's correct. We can develop a trend line. In case number 6, that's exactly what we did. We did the regression line. So it's true. Here's another set theory question, which I'm sure was one that was blow you away. So I'm going to take the font and make it bigger so we can see it. Now, again, you didn't see this. This is behind the scene. This is the instructors. I'm in the instructors edit mode. Okay. Given sets A, B, and C, where set A equals 1, 2, 3, B equals 4, 5, and 6, C equals 7, 8, 9, and A implies B, then B implies A. Now that little curly Q means implies, okay, in the set notation theory, and that answer is correct. And I asked you to see the set materials on set theory and Boolean algebra. And I'd said to you, you had the sample exam, and I'd said, you're going to find the materials for this over in the supplemental website, and I've been over there numerous times. So that's true. Pardon me, is false. Wow, I'm sorry. It is false because if A is not the same as B, B is not the same as A. I've got messed up on my set theory notation. I'm sorry. So the possible it's true. I mean, it's false. Excuse me, my brain's dead. It's 7 o'clock in the morning. So, and you want to go find out what is that little curly Q. Okay, and I have set notation, but just for kicks, let's go over here for a moment. See what the little curly Q implies. In fact, I set notation and things, and let's see, really purple math. Element of back over here. You want to go back and take a look at the set notation theory. I'm sorry about that. It's false. Okay. Now we have another set notation theory. Here is this given sets A, B, C, where A equals, back up here. In fact, I had a at the start of exam 1, I gave you set notation theory. Gave you set notations, what they mean right at the start. It's also in the sample exam. Now let's put this in here. Given that here we get the same sets by 1, 2, 3, 4, 5, 6, 7, 8, 9. Is the intersection of A and B equal the intersection of B and A? Remember, in set notation theory, the U means union. The arch means intersection. We've talked about that. And, are they're not, and are they equivalent? Yes, because sets A and B do not share any elements. So that one answer is true. I told you it shows on set theory Boolean algebra. And here's another item. I'm going to go through each one of these. Give you the sets. This up here. And this is given sets A, B, and C. There's our familiar set elements. A implies B, and the union of C equals the union of A and C. And does not imply B union C. Okay, and that's true. They're equal. And they're equal primarily because of the fact that if you take a look at the intersection of A and C, they have nothing. So there's no set. And if you take this implication here between C is 0, so it's empty sets. And I told you, see the materials of set theory and Boolean algebra. We'll do some more here. I'll plop this up so you can see it. And that's true. Okay. Now we've got yet another set theory question. So like this. In each case, I take over and look at the material on set theory and Boolean algebra. Now let's go back and look at this. And that may have been a surprise, but look, it shouldn't have been because I gave you a sample exam to look at. And given sets A, B, and C, where A is 1, 2, 3, 4, B is 4, 5, 6, 7, C equals 3, 5, 7, 9, A union B is we take everything that's A in A and match it with everything in B. So what a union means is this should be from, I guess, 7th grade, 4th grade, 5th grade, algebra or geometry. A union B means we take everything out of both elements. Now, 1, that's in set A. 2 is in set A. 3 is in set A. 4 is shared by A and B. 5, 6, and 7 are part of B. And we're doing union, so we grab everything. So it's 1, 2, 3, 4, 5, 6, 7. That's the correct answer. Now let's look at this side. Given that sets A, B, C, and the same, given sets A, B, C, it's 1, 2, 3, 4, 4, 5, 6, 7, 3, 5, 7, 9, A union B, A intersection B equals 4. This is where what element is shared by A and B. And the only element that they share is 4. So it's correct. It's true. It's more of these set equivalency problems. Part of this, the reason we give you these set equivalency problems is very simple. You're going to have to do some thinking on this level when we start trying, when you're out at work and you're trying to figure out this. What part of a market am I after? Search certainly comes into this, and this is just also good mental gymnastics to build your brain. Okay. And when we get into working with access, you'll really see this in practical applications when we start doing inner joins, outer joins, that type of thing. Now, given sets A, B, and C, we want to know what is the intersection of B and C. And B and C share 2 elements, 5 and 7. So our next item. And we're going to take a look at the intersection of A and B. And does that imply C? Well, the intersection of A and B is 4. That's the only element they share. They share, pardon me, and yes, 4 and they don't, and C does not, they don't share 4. So it's true. What a good question. It almost looks like the same one, except in this case, it's A intersecting B implies 3. That's 4. It's true. Sets. We'll look at this item. Now, when we take the intersection of A union A and B and the intersection of C, all right, there's nothing wrong with this. Is just like an algebra problem. Think, for example, if I multiply 10 times 2 times 5, okay? 10 times 2 is 20, times 5 is what? 100. Or if I take 2 times 5, that's 10 times 10, it's 100. Or if I take 10 times 5 is 50 times 2 is 100. It's the multiplicative law, and that is operable here. And these sets do not share any similar elements. If you look, you're looking really at the union. You have to utilize, remember, order of operation. And so you're either going to take the union of A and B or the union of B and C. If you take intersection, if you take the intersection of A and B, for example, okay, they do share 4, but 4 is not part of set C, so that's an empty set. If you take the intersection of B and C, you get 5. That's what they share. 5 is not in A, so you have an empty set. If you take the intersection of A and C, okay, they don't share any elements, and so that means it doesn't share any elements of B. So this is like a multiplication problem, and so it's a null or an empty set is true. All right. Now let's say this. I'll get another spreadsheet question. A spreadsheet cell displays of 100. It is defined as what? Typically, it's defined as a value. Okay. A possible answer would be a label or a formula, and it's none of the above. Okay. It is page 16 in the Solvent textbook. Says if the spreadsheet displays 100, it's defined as a value. Okay. We've talked about, what's in the formula bar versus what's displayed in the sheet in the cells. Correct answer there is value. Now we have a little bit of a play on that. I'll make this a little bit bigger. If a spreadsheet cell displays 3/8/2006, it is defined as a value. No, it's defined as a date. So that's false. But true, you got it right. But false, correct, because it's defined as a date. Now, granted, underneath there is a number. But what I'm talking about is how it's displayed. And the way that the number gets displayed is you choose up there in the numbers how to format it or display it. Okay, we've talked about that. We even did this in case 10 when we took that date and it was shown, and then we compared it versus a date in another part of the spreadsheet where we did those receivables, and we could subtract the two of them. Okay, but when it's displayed as a date, it's a date. You have to convert it back to a number. Now, here's another. And pages 16 and 40 in the Solvent book are really where you need to take a look about this. Let's take this. Like that, a little bit bigger, so you can see it. If cell C5, defined as B3, is copied to cell F7, and F7 is defined as what? Well, let's go down here. And it's E3. Okay. Now, here's the answer. The $3 equals an absolute cell address, and B indicates a relative cell address. So the rows stayed the same, but the column moves. So you went from B to C and C to D, and then D to E. In other words, from column C to column F. because remember, when you had that cell formatted, okay, you put a $sign in front of the number, which is the row, but you didn't do anything with the column. As I say, you can try this in Excel and see for yourself. That's what I've talked so much about. And you can do it yourself and see how it's defined. And if functions can be nested, if functions can be nested, in other words, if within an if, is that true? Absolutely. You saw that in the very first case. I think I don't need to increase this right here. It says if P implies Q and P is false, then Q is what? Let's see what the answer should be. So if P implies Q and P is false, then Q is phi. Why? Because P implies Q. Earlier we did it if P not implies, which means the opposite. In this case, we're saying if P implies Q and P is false, then Q is false. And that's from that Wilson book. We'll use it with the lesson on truth tables. Also there. We have if P implies Q and P is true, then Q is a little bit different take on it. Let's go up here and take a look now. Look at the question. P implies Q and P is true, then Q is true. Just like if P is false and it implies Q, then Q is false. Now, this case, in this case, this is implication. If P implies Q, P is true, then Q is true. Why? Because P implies what Q is. And again, I tell you, the Wilson text, we don't use it, but the lesson on truth tables, that's over there. Now, there's another one. And again, you had a sample exam to work with that had many of these types of questions. And I think most of you took that to heart because the scores were far better than what I thought they'd be when I looked at it this morning. Set intersection is equivalent to the Boolean what operation? The Boolean and. Okay? If we use Boolean or, it means X or Y, which really means a union. I'll take either one. But if you use an intersection, okay, then you're saying that they match. Okay? And so that's an intersection and. So Boolean and is an intersection. Boolean or is a union. And I probably followed up with a question on that. Yep, I sure did. Set union is equivalent to the, I give you the set theory and Boolean algebra there, that resource, some materials on that. There's a PowerPoint, in fact, I think. No, it's up here. On largest, you can see it. Set union is equivalent to the Boolean and, but the correct answer is or. I'll take either one, which means you've just created a union because you've taken all the elements of both sets. But if you want and, then you're implying an intersection. The Boolean union is or. And you can tell the see the materials on set theory and Boolean algebra. PowerPoint thing about having an ideal is how many basic steps. And I asked you, is the PowerPoints over there in the supplemental website? And all you have to do is go over there and take a look to see. There's 5 steps. I said, see the PowerPoint. That was a question that was to get you to say, wow. Oh, here's some other stuff. Cardinality of the set 3, 4, 5, and 6. Let's look at that one. Looking at the cardinality. Cardinality of the set 3, 4, 5, and 6 is 4. Cardinality means how many are there in there? And there's 4 elements. And again, it's from the materials on set theory of Boolean algebra. The intersection of row and column is called a cell. Yeah. You open up Excel, columns and rows, and the intersection is the cell. That should have been right. Should have missed. No one should miss that. The payment function Excel can only be used to compute mortgage payments. No, that's false. It can be used to compute any kind of payment, not just mortgage payments. Payments on a credit card, payments on your house. It's not limited to what particular type of question. All right. Now we'll look here, and this back up here, it says the range B4 to D7 denotes, represents a block of how many cells. Okay. Well, let's scroll down here and take a look. The possible answer is 16. All right. B4 through D7. You can open up an Excel sheet and look for yourself. But I give you a general answer. Column B to column D is 3 columns. Okay. And row 4 to row 7 is 4 rows. 3 times 4 is 12. So the possible answer is 7. But the correct answer is 12. Because I've got, let's go back up here and take a look at it for a minute. Think about this. B4 to B7. All right, to compute the number of cells in that array or that block of cells, I have B, C, D. That's 3 rows. Okay. Then I have 4, 5, 6, and 7. That's we had 3 columns, 4 rows. 3 columns, 4 rows. 3 times 4 is 12. So the array is 12. There's only one kind of graph available in Excel. That one's false. We work with graphs a lot. Now, I'm kind of laughing. Look, folks, some of these you should just kind of grin with the songs and say, yeah, this is a given. And many of these questions are. You know, we've worked with, I don't know how many graphs we've worked with in Excel in the cases we've done. Okay? So, when I tell you, go take a look at the page 60. I'm referring to the Solve It textbook. Now, those are the correct answers, the rationales. So I've pretty much covered exam 1, part 1. And I'm going to cancel this because I'm not going to do any changes with it. If you have a question you want to challenge one of them, particularly some of the set theory ones, give me an email or I'll take a look at it and see. But I think I provided you all the resources. And goodness, I give you an example, give you a sample of exam 1, which is almost a copy of this one. And it looks like a lot of you took it to heart because you went over and you did pretty well. Well, that's pretty much it. Now, what I'm going to do is a third recording. I'll do it later today. It's Friday morning, and I've got to get cleaned up so I can go in and sit through the mentor lecture with you, bunch of yahoos. So, I'm kidding you. So, I'll see you over there this morning about 10 o'clock, Shawnee. But for now, I'm going to say this. I'm going to post it, and this is this is 9/21/17 part 2, and I'll label it for you as well.